Good morning, ladies and gentlemen. Let's go ahead and get started. Do now. Pause the video, answer this question in your notebook. A ball starting from rest accelerates down a track in 2.5 seconds. If its final velocity is 6.2 meters per second, what is its acceleration? Show up your work. Do it, pause it. All right, let's do it. Okay, so first things first, let's go ahead and information mind. A ball starting from rest.
What does that mean?
Okay, so starting from rest, that means in the very beginning, from the start, initially it's going to be chilling, not moving at all. So I'm going to put V initial, and we said it's starting from rest, so it's 0 meters per second. It accelerates down a track in 2.5 seconds. I know it's time because I've got seconds there. Its final velocity is 6.2 meters per second. Okay, what is its acceleration? What was the equation for acceleration? It's like acceleration equals the change in velocity over time, which equals V final minus V initial over, I just start change in time. Okay, let's go ahead and plug this in. So we know our V final was 6.2 meters per second. And then our initial was 0, sweet, less work, divided by time, 2.5 seconds. Okay, that's gonna equal, I'm gonna put my answer right down here because I'm running out of space. So I'm gonna say 6.2 minus 0, I'm just gonna not include that, divided by 2.5 gets me 2.48. Sweet. 2.48, what, Miss Moore? 2.48, we're talking about acceleration, meters divided by seconds over seconds, meters per second. Sweet. Let's talk about our units now. So we need to divide fractions. Whoa. How do I do that? So here's a fraction, and I'm going to divide. Here's a fraction.
Oh,
so
now that's a fraction.
Yeah, just put it over 1.
Can you do that?
You can.
Okay.
So what I'm going to do is I'm going to take this number, and I'm actually, right now I've got division. We want to multiply it by what we've got here. I'm going to flip it and multiply.
Sweet.
Flip it and multiply. So I'm going to go ahead and flip this up here. I'm going to say, not 2, S over 1. Oh, sorry. Wrong, Miss Moore. Flip it. You didn't flip it.
1 goes on top, S goes on the bottom.
Okay, this goes away. We're done with it now. And if we read this across, okay, we've got M on the top, and we've got 2S. We've got 1, 2, S squared on the bottom. Okay, that's an equal sign.
That's easier to write, isn't it?
Yeah, so we're going to say 2.48 meters per second squared.
Sweet.
And that is how you divide fractions. A ball rolls down the track and across the table. What is the difference between the motion on the track and the motion on the table?
Have they seen that before?
They have seen this before. Ladies and gentlemen, would you please look in your notes at the Get the Ball Rolling lab, and you should be able to find something in your lab notebook. Oh, that's pretty steep. Hold up. It's a little too steep. Okay, let's draw that more like this. It looks like this. And you're looking for your motion diagram. This is where the ball was accelerating down the track, and this is where it was coasting on the table. This was the track. This was the table.
And instead of coast, I'd use constant.
Oh, that's a good idea. That's a little hint right there.
Did I give him a hint? Uh-oh.
That's right.
Cheat!
Constant. Okay. So a ball rolls down the track and across the table. What is the difference between the motion on the track and the motion on the table? So if you look back at your motion diagram, you should have drawn something like this. And these are getting further and further apart. Why is that?
They're speeding up.
They're speeding up, right? We're accelerating down the track. Our velocity is speeding up down the track.
Yep.
Now, how is that going to be different than what we have here?
Well, it can't go down anymore.
It can't go. It definitely can't. So we're going to go ahead, and I'm going to go ahead and equally spacing these out. Must end right there. Right there. Okay. Sweet. Okay. So what is the difference between the motion on the track and the motion on the table? Well, here we have constant motion on the table. Our velocity is going to go the same throughout, but over here it's speeding up, it's accelerating, right?
Yeah, because it's going downhill.
It's going downhill. It's what happens when you go downhill. Let me see if I can do this. There we go. A ball rolls down the track in 1.49 seconds and goes 1 meter on the table in 0.81 seconds. What is the speed on the table? What is the acceleration on the track?
Can we put that data on your...
We can do that. Let's go ahead and put it over here. So, actually, before we do that, let's talk about what equations we can use on these certain areas. So, we know if we want to find constant velocity, we know that we can say V equals S, not V equals, V equals the change in x displacement over the change in time. Okay, or V equals G over T, any of the above. Over here to find acceleration, we can use our equation. Over the change in time.
Okay.
Back over here now. A ball rolls down the track in 1.49 seconds. I'm going to write that over here. Time equals 1.49 seconds.
That's
for
on
this
the
part.
track.
Yeah. I'm going to go over there. Okay. And goes 1 meter on the table. Okay, so my distance here, or my delta x, equals 1 meter. Okay, it's the same thing as this, distance delta x. In 0.81 seconds. So my time is 0.81 seconds. Okay, what is the speed on the table? Let's start with that. Okay, so let's go ahead and find this answer. So delta x was 1 meter divided by my time, which was 0.81 seconds. So 1 divided by, my batteries are low. 1 divided by 0.81 seconds gives me 1.24 meters per second.
So that's how fast it's going on the table.
Yeah. Okay. So right here, we'll say between here and here, it's going 1.24 meters per second.
Okay.
What's the next question? What is the acceleration on the track?
How do you find acceleration?
Okay, we've got our equation here. What do we need still? Well, we've got the time, right? So that's good.
Oh, you know what? You've got X up there. That should be V.
Oh, you're so right. You
Hey,
guys.
just use your finger and
Yeah,
take that
yeah.
bottom thing off.
Sorry, you guys. Sorry, you guys. Yeah, what am I going to do with position? Okay, we need velocity. So V2, V1. Hopefully by now you're like, Miss Moore, change it. Miss Moore, Miss Moore. Where were we? Oh, yeah. So we have the time here. And so our initial velocity, we're starting up top here, right?
Yes.
And we're holding the ball before we let it go, right?
I remember doing that, yeah.
So our initial velocity, our V1, or our initial velocity, is going to be 0 meters per second.
How can you find the final velocity?
Okay, so final velocity, what is that going to be? So that's right here, right?
Oh, that's a velocity at the bottom of the track. Yep.
This is the velocity at the bottom of the track. It looks like it's probably going to be the same as all of these ones, right?
I think so. It's not going to go any faster.
So let's go ahead and use 1.24 meters per second right there. We can do this now, right?
Yep.
Okay, I'm going to erase this so I can have some room. Velocity final, or velocity 2, same thing. 1.24 meters per second minus 0. Sweet. Divided by 1.49 seconds. And let's do that. 1.24 divided by 1.49. And I get 0.83. 0.83 meters divided by meter per second, or meter per second squared.
Sweet. What did we just do?
What do we do? This is how much the ball is accelerating as it goes down the track.
And how do we get that?
Well, we got that by first drawing our motion diagram and figuring out what the velocity or speed was on the table. That turned out to be my final velocity, my
That's
V2
important.
that I put right here. And then I was able to solve for acceleration over here. Okay. What's next?
Let's stop for a moment.
Yeah. Acceleration is a vector quantity, just like how velocity and displacement were. The direction depends on the relationship or the difference between v final and v initial. If the change in velocity is positive, my acceleration is positive.
Makes sense.
If our change in velocity is negative, our acceleration is negative.
A simple thing. Can you give us some examples?
Absolutely, let's do it. Let's take a look at this. If my velocity final is 10 meters per second, and my initial velocity is 5 meters per second, is this going to be really struggle? There you go. Sorry. Is this going to be a positive or negative acceleration?
Guinness más macho.
So final minus initial, this is going to give us a positive number, right? So our acceleration will be positive. And I'm doing 10 minus 5 in my head.
Yep.
Now this one, 5 minus 10, that's going to give me a negative number, negative velocity, which is going to be negative acceleration.
Little minus a big.
So here we've got negative 5,
Yep.
negative 10. This one, it helps me if I write it out, minus a negative 10, okay? And I like to do my math like this. That's going to give me a positive 5, which means our acceleration is positive.
It's a simple thing.
Yeah, so what you need to know is that if the velocity on the top is positive, the acceleration is going to be positive.
Simple.
Yeah. Okay. Boop, boop, boop. Oh, this is important.
How do you do word problems?
Yeah, so word problems are life. So we are going to be using these information mining skizzles throughout the year. I'm going to go ahead and read them first, and then we'll do a practice problem with them. Read until you come to a number. Write number and units. They should be writing this down. Write this down. Write number and units. Identify what variable it is, and repeat. What is the question? What equation should I use? So I'm actually going to do the first one, the first homework assignment that you guys are going to have.
What page is that on?
Page 97, 17 through 20. Don't check with your partner because you don't have a partner, but I'm going to put this up here for now. So come check this out. Page 97, we're going to start with number 17. It says, the first thing I'm going to do is read until I come to a number. An Indy 500 race car's velocity increases from plus 0.40
That's a number.
meters per
Write it
second.
down.
Okay, plus 0.4. Oh, sorry, wrong. 4 meters per second. I'm just going to call it 4. Okay, to plus 36 meters
That's
per
another
second.
number. Write it down.
36 meters per second. Okay, over a 4-second, Jesus, 4-second time interval.
Okay.
Okay, so I've got read until you come to a number. Okay, write the number in units. Identify what variable.
Oh.
Okay, all right. So meters per second. I know that's velocity. Okay, and I know this is meters. Okay, we've got two.
Which one
velocities.
came first?
Okay, an Indy 500 race car's velocity increased from this to that. So this must be initial. That must be the final. Seconds. This is time.
Sweet.
Okay. What is the question? What is average acceleration? Okay.
And
What equation? Okay, well, I know the equation. So acceleration equals v final minus v initial divided by time. Okay, here we go. So velocity final is 36 meters per second minus 4 meters per second, all divided by 4 seconds. Okay.
parentheses.
Okay, so really good point. So parenthesis, 36 minus 4, close parentheses, divided by 4 equals 8. 8 what? Let's see, we're talking about acceleration, meter per second, which is meters per second squared.
Information mining.
That's how you do it, ladies and gentlemen.
Word problems can be intimidating. You gotta know, you gotta start with something.
So So every single time you do a question, when you're like, I just don't know what to do, these are the 1, 2, 3, 4, 5, 6 questions you need to ask yourself, or 6 things you need to do before you come and ask me. I want you guys to pause the video here. You are going to finish number 18, 19, and 20. And then you're going to come tomorrow to class with those answers, and we can talk about it, bring your questions, and then we'll rock and roll.
Okay, you guys, so to get to the bookwork, you're going to go to Golden Valley's website, click right here. You're going to go to Library, eText. Scroll down to Science. And all the way on the left, you're going to find Physics Principles 2002. Dang, that's old. And the next thing, we are on chapter 5, so here's the PDF for 4 and 5. If you download the book, it's a good idea because that way you can access it without Wi-Fi, which might be a good thing for you. If not, just view it, and you're going to go all the way to page 97. Oops, too far. Here it is, page 97, and you're doing 17, 18, 19, and 20. This is how you get to the e-text. If you have any questions, make sure you email me, and now you know where to get the questions. Good luck.